Hello everyone. Today we are going to learn quadratic equations, especially quadratic equations in one variable. Now as the name suggests, it has only one variable and the highest degree of the variable is 2. Alright. Now let's take some example. So if I have 2x square plus 5x plus 2 equals 0. Okay. If I can say 2x square plus 6 equals 0. This is also quadratic equation. If it is 3x square minus 5x equals 0. So this is also one kind of quadratic equation. 1 half x square plus 3 and a fourth x plus 5 equals to 0. So these all are the examples of quadratic equations. Now if I talk about the standard form of the quadratic equation, it is given as ax square plus bx plus c equals to 0, where a is not equals to 0. So remember, the coefficient of x square never be 0. If it is 0, then what will happen? So if the coefficient of x square is 0, then it becomes a linear equation and it is no more the quadratic equation. So remember that, okay? So any equation which is, let's say, x square plus 5x plus 6 equals to 0, this is the standard form. Also if I say 3x square minus 2x minus 1 equals to 0, this is also a quadratic equation, right, which is in standard form. Now when the constant term is missing, okay, so let's say if I have 3x square plus 5x equals to 0. Here the constant term is not there. C is not there. So this kind of quadratic equation is called adequate quadratic equation. When the x term is missing. Okay, if you have simply x square equals to 9. So this is also a quadratic equation which is in pure form. So it is called pure quadratic equation. Also if I say 4x square equals to 25. So this is also pure quadratic equation. Alright. Now the roots or solution of quadratic equation. So in general, any real number, alpha is called a root of the quadratic equation ax square plus bx plus c equals to 0 if it satisfies a given equation. Means what? So let's understand with the example. Let's say I have 2x square plus 2x plus 1 equals 0. This is one quadratic equation. If I'll put x equals to minus 1 here. So let's understand what will happen. So minus 1 square plus 2 into minus 1 plus 1. Now when I simplify this, I'll get 1 minus 2 plus 1. This gives me 0. Here we got the 0, right? So this is nothing but the x equals to negative 1 is called the root or the solution of this equation. Alright? Okay. Now we have to find whether this given equation is a quadratic equation or not. So we understood that the standard form is ax square plus bx plus c equals to 0. Now here power of x is 4. So is it a quadratic equation? No, we have to simplify this first. Okay, so if I simplify this, x to the power 4 whole power 1 half plus 6 equals to 0. Do you remember the exponent rules? So I can apply the exponent rules here and I can simplify the power as 2 and I'll get x square plus 6 equals to 0. So this is the quadratic equation form. So yes, it is. Right? Okay. Now here one more example is given. If I see here x power 3 is there. Alright. And it seems a very complicated equation. Okay. But let's not afraid of it. Okay. We'll simplify it first using the identity which we know. Okay. Here it is x minus 2 whole cube. So I can apply a minus b whole cube identity. So let's do it. So I'll write this left hand side as it is. X cube minus 4x square minus x plus 1 equals. Now apply the identity. So what do we get? X cube minus 3 into x whole square into 2. I'm just putting the values, okay? We'll simplify this in the next step. 3 into x into 2 square minus 2 cube. Now let's simplify this. So what do we get? X cube minus 4x square minus x plus 1 equals x cube minus 6x square. Here it is 2 square, 4 into 3, 12x minus 8. And now I can easily say that I can cancel out this x cube, okay? And I can simplify by bringing everything on the left hand side. So what do we get? 2x square minus 14x minus 8 becomes a plus 8. So 9 equals 0. And it is the standard form, ax square plus bx plus equals to 0. So yes, it is the quadratic equation, right? So I can say yes for this. Alright. Now here we have to check, here one root is given which is 2 upon 3 and we have to find the value of p. Alright. Now we know that if 2 upon 3 is the root, then it will satisfy the quadratic equation, right? So you can use a factor theorem, right? So we already know that. I can substitute the value of the x as 2 upon 3 power 2 plus 4 into 2 upon 3 minus p equals 0, right? So what do we get? Let's simplify this. So 3 4 upon 9 plus 8 upon 3 minus p equals 0. Now we know how to simplify this fractions, right? So I'll get 4 upon 3 plus 8 upon 3 minus p equals 0. And on simplifying this, 12 upon 3 which gives me 4 minus p equals 0, and hence I'll get p equals 4. So this is how I'll get my answer. Alright, now discriminant of the quadratic equation. So the standard form is ax square plus bx plus c equals 0, where a is not equals to 0. So the discriminant value d equals b square minus 4ac. Now why it is so important? So we can decide the nature of the roots of the equation. So let's take the example. First of all, we'll write some conditions, okay? If b square minus 4ac is greater than 0, then we have, the equation has two distinct real roots. Distinct means different, okay? Now the second condition is when b square minus 4ac equals 0, then the equation has equal roots, two equal roots which are real. Alright, and the third condition is when b square minus 4ac is less than 0, then the equation has no real roots. Alright, so now I am taking one example. Let's say I have x square plus 2x plus 1. Now we know that we can find the value of x by trial and error also. So if I'll take x equals to minus 1, then that satisfies the equation and that is the root. Okay. So for this is nothing but x minus 1 whole square form. Right. So in this case there are two equal roots. Okay. Here if I'll find the discriminant, so d is equals to how much? B square minus 4ac. If I'll take, I mean compare the with the standard form, I'll get a equals to 1, b is 2 and c equals to 1. If I'll put it here, so what do we get? We'll get 0 here. So it has two equal roots, right? So hence it is verified. Now let's understand with one more example. Now here we have to find the value of p when given that the equation has equal roots. Now equal roots means second condition when discriminant d equals to 0. So first of all we'll compare this equation with ax square minus plus bx plus c equals to 0. Remember the x term will be positive, okay, for us. So if here the coefficient is negative, then you have to consider the sign as well. So for example here a is equals to 3, b equals to negative 12 and c is equals to n minus 5. Now discriminant value is 0. So we'll substitute this in the formula. So b square minus 4ac equals 0 for equal roots, right? Now we'll substitute this value. So negative 12 square minus 4 into 3 into n minus 5 equals 0. Now let's simplify this. So 144 minus 12 into n minus 5 equals 0. 144 minus 12n plus 60 equals to 0. So what do we get? 12n is equals to 204 and on simplifying n is equals to 17. So this is how we can find the value of the unknown. Alright, now here one situation is given and we have to find whether the situation is possible or not. And if it is possible, then we have to find the present ages of the given friends. Okay. Now first of all let's understand. The sum of ages of two friends is 20 years. Alright. 4 years ago the product of their ages is 48. Alright. Now what do we do? Remember, here we are talking about quadratic equation in one variable. So we have to write our equation in one variable. Okay. Now let's understand this. So I'll make a table for a simplicity. So what I'll write? The first friend. Okay. Second friend. Now their present age is first. Now sum of their ages of friends is 20 years. So if the age of first friend is x years, this is in terms of years. So the second friend age will be 20 minus x, correct? Now 4 years ago. So see, 4 years ago means the age of first friend was x minus 4 and the second friend was 20 minus x minus 4. Most of the children are making mistake here. not subtracting 4. So it is important to understand. Okay, 4 years ago. So whatever the percentage, you have to subtract 4 from it. So what do we get? We'll get 16 minus x. Now they are saying that 4 years ago the product of their ages was 48. That means x minus 4 into 16 minus x equals 48. This is given. And now I'll simplify this. So what do we get? 16x minus x square minus 64 plus 4x equals 48. On simplifying this, I'll get negative x square plus 20x minus 64 equals 48. Okay, I'll simplify this by bringing the 48 other side. So I'll get minus x square plus 20x minus 48 plus 64. That gives me 112. And when I I'll multiply all the sides by minus 1. So I'll get x square minus 20x plus 112, which is equals to 0. Alright. Now, to understand the situation is possible or not, we'll find the discriminant. Okay. So d is equals to b square minus 4ac. So what does it be? So b is negative 20 square minus 4 into 1 into 112. I just compare this quadratic equation into standard form. Okay, and I'll get 400 minus, this is 448. So this is minus 48. Now, do you remember, if the discriminant is negative, okay, it is less than 0, then no real roots are possible. No real roots, okay, are possible. So, this situation is not possible. Okay. Hope you understood this. Alright. Now, we are going to learn how to solve the quadratic equations. Okay. So, there are different methods available where we can use them and solve the quadratic equations and find the solutions. Now, here, today we are going to learn the factorization method. Okay. Now remember one thing, if you follow all the steps, you can solve any quadratic equation by factorization. Okay. So let's understand each step with this example. Now step 1. Clear all the fractions if any and write the given equation in the standard form. Now remember the standard form is ax square plus bx plus c equals to 0 form. So let's convert this fraction 1 upon 8. Okay, so we'll multiply all the terms by 8 to get rid of this denominator. So what do we get? 16x square minus 8x plus 1 equals 0. So we multiplied all of them by 8. So now this is the standard form of the quadratic equation. Now second step, factorize the product of the coefficient of x square and the constant term. Okay, so first of all, okay, the coefficient of x square is 16 here. So 16 and 1, we have to factorize this. So that, okay, such that you get the, see, they express the coefficient of the middle term as the sum or the difference of the factors. Now, the factors of 16. So, let me write the all the factors of 16. So, 16 ones are, then 8 twos are, or 4 fours are. Correct? So, these are the factors. What we get? Now, I'll find, now see, one important tip, okay. Here when the C, okay, C value is positive, okay, then it is the sum. So, let me write here. If is positive. Okay, so C greater than 0, then you have to express this as the sum of the factors. Okay, sorry, sum of the factors, otherwise difference. All right. Now what does it mean? So here, see, when I think about 16 and 1, if I add or subtract, do we get negative 8? No. 8 and 2, again no. But 4 and 4. So if I add 4 plus 4, we'll get 8. Correct? So what do we do? Here I'll write this middle term by splitting this using these factors. Okay, so 16x square minus 4x plus 1 equals 0. So what did I do? I splitted this middle term, okay, using these factors, and now I can group them and factorize them. Okay, so here for the first group, the common factor is 4x. Now when I write 4x as a common factor, here also 4x minus 1 I'll get, and now here common factor is just minus 1. So I'll get 4x minus 1. Now remember one more thing, a very important tip. You should get this two brackets same. Right? See, you already learned factorizing factorizing the polynomial in your previous grade. So you know this, right? Now what I can write this as 4x minus 1 and 4x minus 1 equals 0. Now step 4 is apply the zero product property. Now what is zero product property? When you have two linear factors, then you can compare with 0. So what I can say, 4x minus 1 equals 0. Here both are same, so if you write this way or not, doesn't matter. So now I'll get x equals to 1 over 4. Here the roots are same, okay. Both the cases will get x equals to 1/4. Right? So this is the solution of this given quadratic equation. Oh my god, it is so difficult to solve. Is it what you think? So don't afraid, okay? If the given equation is given in terms of fractions, don't afraid. First of all, we'll convert into standard form. Alright. Now how to do that? Take the LCM. Okay, so the denominator on the left side, x minus 1 and x. So the LCM is what? X into x minus 1. Now we have to multiply the first term by x square and the second term by x minus 1 square. And here I convert the mixed fraction form into improper. Alright, now we'll simplify this. So what do we get? X square plus x square minus 2x plus 1 into x minus 1 upon 5 upon 2. Now we'll simplify the numerator as well as we'll cross multiply them. Okay, we'll do the two things together. So what do we get? 2 times 2x square minus 2x plus 1 equals 5x into x minus 1. Now this is 4x square minus 4x plus 2 equals 5x square minus 5x. Now bring everything on one side. Okay. Now here if I see 5x square is bigger than 4x square, so I'll bring everything on the right side, but I'll write this way. Okay. So I'll write x square. This minus 4x goes the other side, becomes plus, and I'll get minus x only, and then minus 2 equals 0. So this is what I simplified. Okay. Now here step number 3. I have to multiply the coefficient of x square and the constant term. So 1 into minus 2. So I have minus 2. And now I'll factorize this. So I'll get 2 ones are. Okay. If I subtract them, I'll get just 1 here. Correct? remember the tip which I have given. If this is negative, then you have to subtract the factors which you are getting. Okay. So this is what I'll get. X square minus 2x plus x minus 2 equals 0. Now it is simple. Factorize this. So x into x minus 2 plus 1 into x minus 2 equals 0. So we'll get x minus 2 x plus 1 equals 0. Now apply the 0 product rule. So what I'll get, x minus 2 equals to 0 or x plus 1 equals to 0, and we'll get x equals to 2, x equals to minus 1. So these are two roots, okay, of the given equation. Isn't it easy? Okay. Oh my god, these are square roots. Again difficult question? No, it's not. Okay. Follow simply the instructions which I have given. Alright. Now, is it in the standard form? What is the standard form? Remember, ax square minus, plus bx plus c equals to 0. This is the standard form. So yes, this given equation is in the standard form. So let's apply the steps. So we'll multiply a and c first. Okay. So here it is 3 square root of 2 into minus root 2. Okay. So what do we get? Square root of 2 into square root of 2 is 2. 3 into 2 is 6. So I'll get minus 6. Now factorize this. Okay. So we know that 3 into 2 is 6 and 3 plus 2 is, what do we get? 5. Okay. But it should be a subtraction. So 6 ones are 6 also. That gives me 6. And 6 minus 1 is 5. So remember, I told you whenever this term, okay, this term is minus, you have to take the difference and not take the sum. Here we have to add them. Okay. But this is not possible here because it is negative. So we have to consider the difference. Okay. So now let me write this. 3 square root of 2 x square minus 6x plus x minus square root of 2 equals 0. Alright. Now same thing, okay, same steps we have to follow. Group them and then factorize. So here the common factor is what? See, 3 is a common factor. Now 3 2s are 6, but 2 root 2 is also there. So 3 root 2 and x is common. So what is left here? Just x and then minus square root of 2. Okay. Now plus 1 into x minus square root of 2. Do you remember I told you this should be same? So yes, it is same. Now what I'll get? X minus square root of 2. 3 square root 2x plus 1 equals 0. Now next step is 0 product rule. So when I'll apply that, I'll get x minus square root of 2 equals 0 or 3 square root 2x plus 1 equals 0. Now I'll get x equals to square root of 2 or x equals to minus 1 upon 3 square root 2. So the roots, okay, the solution of this equation is square root 2 minus 1 upon 3 square root 2. So this is my answer. Alright. Now here, okay, we have to find the value of m when the equation has the equal roots. Okay. Now do you remember when the equation has equal roots, the discriminant is 0, correct? So first of all, we'll compare the given equation with the standard form. So my standard form is ax square plus bx plus c equals to 0. On comparing, what do we get? A equals to m minus 2, b equals to minus 5 plus m, and c is equals to 16. Alright. Now b square minus 4ac equals 0. Why? Because equal roots. Okay. So I'll substitute the values. Okay. Now minus into 5 plus m whole square. Minus 4a is m minus 2. C is 16. 0. Okay. Remember, we'll do everything step by step. Okay. Substitute everything and do it step by step. So it is super easy to solve. Now minus square, that becomes a positive. Now 5 plus m whole square. So apply a plus b whole square identity. So what do we get? 25 plus 10m plus m square. Now here, first of all, 16 fours are 64. So I'll write 64 times m minus 2 is equals to 0. Okay. Now I'll simplify this. Okay. So 25 plus 10m plus m square minus 64m plus 128 equals 0. Now we'll simplify this. So m square, now my plus 10m and minus 64m. So that gives me minus 54m plus 128 and 25. If you add them, what do we get? Okay. And now we'll see, this is again a quadratic equation. Okay. M square minus 54m plus 153. So we'll apply the same rules. So 153 into 1. Coefficient of m square is 1. Now I'll factorize this. So 3 into 51. Now 51 plus 3 is 54. So I got my fractions. And I'll write this as m square minus 51m minus 3m plus 153 equals 0. So what do we get? M minus 51 and m minus 3 equals 0. So applying the 0 product rule, m minus 51 equals 0 or m minus 3 equals 0. So what do we get? M equals to 51 or m equals to 3. So here we got the two values of m. Okay. So this is the solution of this given question. Do you remember I told you there are several ways of solving a quadratic equation? So now here one more method we are going to learn, which is nothing but using quadratic formula. Now we already learned the discriminant, right? Discriminant d equals to b square minus 4ac, correct? So now we can use this discriminant to find the solution. So here the solution of the quadratic equation ax square plus bx plus c equals to 0 is given by minus b plus or minus square root of discriminant upon 2a. Okay, I can write this as minus b plus or minus square root of discriminant upon 2a. Alright, now here one example is given. We'll solve using this quadratic formula. So first of all, we'll compare this given equation with the standard form. And I'll write the values. A equals to 2, b equals minus 6, c equals 3. Now, I will suggest you to first find discriminant, okay, so that you can understand the nature of the root. Now, d is equals to b square minus 4ac. So, using this minus 6 square minus 4 into 2 into 3. So, what do we get? 36 minus 24, and this gives me 12. So, I can use this discriminant value to find the solution of it. So, now the solution is given as x is equals to minus b plus or minus square root of d over 2a. Now, let's substitute all the values here. So, minus of minus 6. Remember, many students are making a mistake while not putting the negative sign here. Okay, it is minus b and the value of b itself a negative value. So you have to put minus of minus. Now it is plus minus square root of 12 upon 2 times 2. Now what do we get? 6 plus or minus, this is 4 into 3, so I'll get 2 square root 3 upon 4. And now I can simplify this by taking a common factor 2. So I'll get 2 into 3 plus minus root 3 upon, I'll just write 2 into 2 again because I can cancel it out. So the x value is 3 plus root 3 upon 2, or I can say 3 minus root 3 upon 2. So this is my solution. Let's solve one more problem. So same way, okay. First of all, we'll compare using the standard formula. So a equals 1, b equals 1 and c is equals to minus of a plus 2 into a plus 1. Alright, so let's find the discriminant value. So d is equals to b square minus 4ac. So what do we get? Minus 1 square minus 4 into 1. Now consider the negative sign for c. So we'll get a plus 2, a plus 1, and now I'll simplify this. So we'll get 1, now minus minus becomes a plus, 4 times a plus 2, a plus 1. Now let's simplify this. So 1 plus 4 into, now first of all I'll multiply this to brackets. So I'll get a square plus 3a plus 2. And on simplifying this, I'll get 4a square plus 12a plus 9. So this is nothing but 2a plus 3 whole square. So the discriminant value is greater than 0 because it is a perfect square. And now I can find the solution. So the solution is nothing but x equals minus b. So I'll write this plus or minus square root of d. So this is nothing but 2a plus 3 whole square upon 2 times 1. See, I have substituted all the values first. Now what I'll get? Minus 1 plus or minus the square root gone and we'll get 2a plus 3 upon 2. Now I'll plus 2a plus 3 upon 2, or I can write x equals to minus 1 minus 2a minus 3 upon 2. And for the first value, what do we get? 2a plus 2 upon 2. So I'll just simplify this as a plus 1. Or I'll get x equals to minus 2a minus 4. So that gives me minus of a plus 2. So these are the solution of the given equation. Alright. Now for this question, we'll start drawing the figure first. Alright. Now here it is given a circular path. So I'll just draw the circle first. Okay. Now let's understand it word by word. Okay. Now it is saying that a pole has to be erected at a point on the boundary of a circular park of the diameter 13 meter. Now, first of all, what it says, the diameter is 13 meter. So this is the diameter and the value of this is 13 meter. Such a way that the difference of the distances from two diametrically opposite fixed gates. So here there are two gates, I mean the gate A and gate B, which are diametrically opposite. Okay. And now see what they are saying, the pole should be there at the boundary. Okay, so let's say the pole is here. This is the pole we are fixing. And the difference of this distances from these gates. Okay, so when I join these 2 points, what I get? One more from here to here. Okay, so they are saying that this distance, okay, AP minus BP, this is equals to 7 meter, and we have to find them. Okay, we have to find AP and BP. Okay, so here to find AP and BP. Alright, now this is a 90-degree angle. You will learn this in your circle chapter. Okay, the angle which is formed by the diameter on the boundary is a right angle. Alright, so this is a right angle triangle. Now let's say if any one of the them is a variable. So let's say this is a variable x. So this is for how much? X plus 7 I can say. Now can we apply the Pythagoras theorem? Yes, we can. So let's apply it. Now what it says, AP square plus BP square is equals to AB square. Now when I put all the values, so x square plus 7 plus x whole square is equals to 13 square. And now on simplifying, so x square plus 49 plus 14x plus x square equals to 169. Okay, now let's simplify this. So 2x square plus 14x minus, now when we subtract this, what do we get? We'll get 120 equals 0. On dividing all of them by 2, what do we get? X square plus 7x minus 60 is equals to 0. Alright. Now remember one thing. Okay, if this is a simple question, so I can factorize this and I can find the square root. But here in the question, they are asking us, okay, is it possible to do so? Now whenever is it possible, a phrase is there, okay, that means we have to find the discriminant value. So I'll find it first. So discriminant is b square minus 4ac. So what do we get? 7 square minus 4 into 1 into 6 minus 60. Right? Remember to include the minus sign, otherwise you will get incorrect answer. Okay. So the discriminant is equals to 49 plus 240. Correct? So on solving this, what do we get? 289. Now once we get the discriminant, we can use the quadratic equation formula. So x is equals to minus b plus or minus square root of d upon 2a, and I can find the value. So minus 7 plus or minus square root of 289 upon 2. Now on simplifying and taking the separate values for positive and negative square root of d. So x is equals to minus 7 plus square root of 289 is 17. So I'll write first positive 17 upon 2. And the second value is minus 7 minus 17 upon 2. Now we'll get here 17 minus 7 is 10 upon 2, which is 5. Okay. Here we'll get a negative value. So how much do we get? Minus 12. So this is not possible, okay, because we are talking about the length of the side of a triangle. So negative we have to discard. So only one answer is there, x equals to 5. So we have to put this pole from 5 meter away from one gate and the second 12 meter away from the second gate. I hope you understood this one. All right. So it seems really a tough question, but again, as I said, don't afraid just looking the fractions. Okay, we'll apply the step-by-step rule. All right. Now, see, if you just observe the numbers. So here, x minus 3, 2x plus 3 gets repeated for this. Okay. So what I'll do first, I multiply everything by this x minus 3, 2x plus 3. So let me write it. X minus 3, 2x plus 3 into 2x upon x minus 3 plus x minus 3 into 2x plus 3 into 1 upon 2x plus 3 plus x minus 3 into 2x plus 3 into 3x plus 9 upon x minus 3, 2x plus 3, and 0 multiplied by that is 0. Now see, this is very easy. So I can simply cancel out this. Here I can cancel out this, and the both brackets are cancelled here. So now this is so 2x into 2x plus 3 plus 1 into x minus 3 plus 3x plus 9 equals 0. Now let's simplify this. So we'll get 4x square plus 6x plus x minus 3 plus 3x plus 9 equals 0. Now I'll keep all the like terms together and simplify. So what will we get? 4x square plus 10x plus 6 equals 0. And by dividing all of them by 2, I'll get 2x square plus 5x plus 3 equals 0. Now I can use two methods. I can factorize this or I can use a quadratic equation. But factorization is easier. So I'll just use 2x square plus 2x plus 3x plus 3 equals 0. So what do we get? The factors are, let me just write here, x plus 2 and 2x plus 3 equals 0. Now 0 product rule. So I'll get x equals to minus 2 or x equals to minus 3 upon 2. Alright, but now if you see here, the conditions are given. X is not equals to 3, x is not equals to minus 3 upon 2. Now why it is given? So because if I'll put x equals to minus 3 upon 2, this fractions becomes not defined. Okay, so that is why. So only one solution I'll get, which is nothing but x equals to minus 2. Alright, easy? Okay. Now I am giving you some practice questions to solve them, and you can answer, you can comment the answers. Alright. Okay. So I hope you understood this topic, quadratic equations, how to solve them using this discriminant values, how to identify the nature of quadratic roots. Okay. So I hope this is clear, and if you have any doubt, please comment so that I can reply you. So please like the video, share the video, subscribe the channel, and thank you for watching.